Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running nationally syndicated radio talk show on computer and technology term podcast. Everyone, welcome into the morning. I had my coffee, if you couldn't tell. I hope that you're doing well and you are ready for today's program, because today on the show we are starting out strong with of course Ralph Bond. It is Friday and he has brought to us a number of stories, usually about 5. I should probably know this off the top of my head. 4 stories today, but don't worry, there's still going to be plenty to talk about, and it's going to be a lot of fun. But before we get into that, everyone, computeramerica.com. That's where you'll find everything, including the show notes, links to all the articles, links to Ralph's website, links to everywhere. We are the de facto replacement for Google. Spread the word. Everyone, and of course, you can find reviews, show notes, past shows, the video archives, the podcast, of course, social media links, all that and more. So everyone, welcome into the program, and I hope that you're doing well. Let's go ahead, bring Ralph on, and yeah, we're just going to have fun with it. Joining us once again, he has been a longtime Computer America correspondent. He is our science and tech trends correspondent for the program. And of course, you may know him from WKEX, but hey, you may also know him as just Ralph. Well, Ralph, welcome back onto the program. Wow, yes.
Of caffeination. You see this big guy here?
Oh, yeah.
This is my huge coffee mug. So I'm right there with you. And I'll
you
tell
know
you what, Dan.
Yeah, well, and of course you're over there on the West Coast, and you're doing it much earlier than I am, and I appreciate that you do. But I guess before we get started, how you doing? How's your week been?
I'm okay. I'll tell you what, though, Ben, with everything that's going on in the Ukraine, oh my God,
you got to stay up on that.
We could sure use some positive news, and that's what we're going to do today. That's what I love about what you and I do each Friday now, is try to bring some uplifting, positive news, thanks to the world of science and technology, and we've got some great stories today.
Absolutely. And I was, really looking forward to a number of these, because they're usually, of course, like your correspondent title implies, science and technology. So it's not just strictly, what is the latest phone and how much battery does it have?
Right.
Right. This gets a little bit more in depth, but you do a good job of breaking it down, and I'll just say your part for you. But as you always do, you have kind of the cliff notes, you have, kind of the highlights of the story as you read them. But if anyone out there would like to read more in depth and be like, I feel like Ralph didn't get that just right, you always source your articles.
Well, yeah. And Ben, to your point, the most important thing about the show notes is what we do, and all we have time to do, is kind of the Reader's Digest simplified condensation of a particular story. And so a lot of times the articles that I draw from for these highlights, if you want to call it that, provide so much more detail with links inside of those articles. If you want to dive deep into the geeky technology of some of these stories and the scientific advances, that's how the show notes can help you. Gets you right to the original source article or articles. Sometimes there's multiples, and you can dive as deep as you want. So that's what it's there for. And go out and get those show notes, everybody.
Perfect. So, but of course you can always watch the live video feed and you can follow along with us. So if you're following along with us, we of course see story number 1 up on the screen. Let's start there.
Yeah, this is really cool. So MIT, good old MIT, creates a new wood-derived composite as tough as bone.
That was me, I'm sorry.
That's okay. So it's a little bell. It's a great story. It's got the good story bell alert. So again, they've created this wood-derived composite as tough as bone. Picked this up from the MIT news website, their news outlet on their own website, which is just fabulous, by the way. And so, Ben, of course, last week you and I talked about a new sustainable disinfectant developed by some scientists in China, made from sawdust that kills deadly microbes. Right. Well, you can kind of think of today's story here. Our first story is kind of part 2 of the wonders of wood. I mean, it's just so ironic that there were 2 weeks in a row with these stories popping up about people doing incredibly clever things with wood as the source. So now there's a new wood-based composite developed by a team at the Massachusetts Institute of Technology that is as tough as bone. And so here's a little bit of background, though, before we go into this more. The strongest part of a tree lies not in its trunk or its roots, but in the walls of its microscopic cells. A single wood cell wall is constructed from fibers of cellulose, nature's most abundant polymer, and the main structural component of all plants. And so within each fiber are reinforcing cellulose nanocrystals, which are chains of organic polymers arranged in nearly perfect crystal patterns. It's so bizarre. At the nanoscale, and when we say nanoscale, remember that means at the tiny size of measured in billions, with a B, billions of a meter, these cellulose nanocrystals are stronger and stiffer than Kevlar, the stuff that's used to make the vests, right, for the police and for the military and so on. So it's pretty remarkable. And that little sound was from my system, so I'm going to close out that app.
You're good.
The MIT team figured that if the crystals could be worked into materials in significant amounts, cellulose nanocrystals could lead to more sustainable, naturally derived plastics that are very, very hard. So scientists at MIT engineered a composite made mostly from wood cellulose nanocrystals mixed with a bit of synthetic polymer. And these organic cellulose crystals make up about 60 to 90% of their experimental composite material. And the researchers found their wood cellulose-based composite is stronger and tougher than some types of bone, not all bone, but some types of bone. And for example, as shown in the picture you're showing everybody right now, Ben, in one experiment, the team 3D printed a human tooth replacement using the new composite. So there's just an unrestrained world of possibilities for this kind of composite material. And again, from wood. So you could take wood waste and put it to use other than particle boards and now other than a disinfectant that we talked about last week. Here's a new additional use.
And when you're going through this article, like the first application I thought about this, like, I don't know, my mind did not immediately jump to tooth replacement, but that was the proof of concept that they kind of did. And I guess like another big part of this is just the fact that 60 to 90% of what we currently use as plastic would just be replaced by wood. So like, it's not like we really change all that much, although it sounds like a better material altogether.
Right.
It's just, we still have we still have a little bit of plastic, but a lot less of it. And that's the cool part.
Well, I think another cool thing too, that comes to mind as you were speaking, is go and look at the MIT News website and their website in general. The range of things that they're exploring, from robotics to electronics to physics to materials research, the range to me is just mind-boggling. And that's another thing that this story, I think, kind of illustrates.
Yeah, and of course, it's even cooler that, because we've been covering 3D printers for quite a while now, that's how they really use this as a 3D printer. So you can imagine all the applications that you could, of course, jump into with that. Great research, and I hope to see a lot more of it because, it's not news to anyone. We have a plastic addiction, a plastic problem, getting different material that can do the same thing is very important. So I like that story a lot, Ralph. So that was story number 1, though. Story number 2, let's go ahead and jump right into it.
Yes, and thinking about the Ukraine, you're going to see how this fits in as well. So the headline here is light, flexible, bionic hand and forearm actually uses artificial intelligence and muscle memory to refine its touch. And I'll explain. Got this from inputmag.com and also the company Esper Bionics, their company website as well. And let's set the stage here. Today's cybernetic prosthetic limbs are cumbersome and sometimes even presenting more challenges to the patient than they try to correct. So that's sort of the global sweeping problem we're facing. But time out, let's explain cybernetics relative to artificial intelligence. So I added this yesterday late, so it's not in the show notes, but I'll update the show notes on my site. So AI, we all know that artificial intelligence, it's based on the idea of creating machines to mimic human intelligence and behavior, whereas cybernetics is the science of human-machine interaction that employs the principles of feedback, control, and communication. So we're talking about a cybernetic prosthetic limb. And again, talk about the Ukraine. Here we go. Ukrainian technology company, Esper Bionics, and God, I hope they're all okay and we're going to make it through because these people are geniuses. Anyway, Ukrainian technology company Esper Bionics was recently granted FDA approval for a new, smarter prosthetic device called the Esper Hand, and you're showing it on the video right now. It's profound, taking advantage of advanced artificial intelligence and machine learning. Ding, 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 machine learning. The Esper Hand is a prosthetic designed to learn and thus improve over time as it's worn by the user, of course. And you have 16 sensors in both the stump socket and within the hand component that pick up on an individual's muscle movements. So designed to learn, improve over time, designed with these sensors to respond to your unique muscle movements. That keep those in mind. It has movable fingers, thumb, and wrist, and will be available in 5 sizes, offering a variety of natural shapes. And the Esper Hand works with Esper's cloud program to keep it continually fed with new and improving user data. That's the sort of cross or symbiotic relationship between the device, the cloud, machine learning, artificial intelligence, all coming together. And a key advantage, here's where it all comes together, here's the payoff. The key advantage of this new device is that it can recognize different usage situations, and the video is perfect timing for this, different situations, and adjust its grip accordingly. So it's not just a blunt, think of like when you're out in a park and you see the cleanup people with those wands with the little grabby things picking up trash. It's just a blunt, open, close, open, close. A lot of prosthetics today are pretty blunt, pretty simple, right? Not this one. This one can adjust its grip intelligently, if you will, to compensate for things like cutting food or opening packaging, using zippers. A moment ago, you showed the woman buttering a peanut butter on a piece of bread. So this is really important. Please check this out if you're interested in medical devices, prosthetics, because this is a real step up. And again, they're in the Ukraine. God bless them. I hope they're going to make it through okay, because what a tragedy it would be if that facility and all that work was destroyed by the Russians. Ugh.
Right. Yeah. And yeah, they certainly have come a long way than a lot of other prosthetics. Now, this scene right here that for people that are watching, I'm wondering if they put like maybe a little bit of silver in the fingertip or something, because you can see she has a smartphone and she swipes the phone to open the phone with the prosthesis. That's cool.
I'm sure they do. Yeah, it's very, very cool. And another side commentary about the Ukraine. Mm-hmm. The Ukraine is a hotbed of tremendous technology research. Very, very forward work across multiple fields. So it's again another reason why this problem in the Ukraine is such a world tragedy. It's just awful.
Yeah, and of course, I'm sure that the scientists that are there, they have a lot of ties with Europe. Even reading their site, they're funded by the European Union, and of course, they're negotiating per your notes with U.S. clinics to kind of bring the technology there. Ralph, I know that there's along with Ukraine and Russia, there's a massive humanitarian crisis in the neighboring countries, because I think it was like 900,000 or something like that have fled Ukraine. I'm hoping that the teams that had the connections and the ability and, of course, the organizations kind of got their people out of there that could get their people out of there. So, I'm hoping an organization like this would be one of them. Yeah.
Oh, yeah, I couldn't agree more. And to tie up the little last nugget on this story, think about the cost of this product. Right now, Esper Bionics is negotiating with U.S. clinics for a price that will be somewhere around the $16,000 to $18,000, which I know sounds like a great deal of money. But when you think about what this device can do, and I'm sure over time, as they ramp up mass production and so on, the price could probably come down. But that's what they're looking at initially.
Right, and then of course they have a lot more that they're going to be working with these neural implants and things like this.
Right.
Yeah, this is the kind of technology, and I know that you've come on the show before, and we've seen we've seen way more affordable things, but they were way more basic. We've seen way more complicated things, but they were very, very experimental, not in the consumer stage. This kind of strikes that middle ground, Ralph. That it's not the cheapest in the world, but it does have a lot of functionality, and it was very cool to see the videos of, like you said, just even holding a piece of bread. You can imagine if you had no sensation in your hand, how hard that would be.
Well, and the video too. Also, I think one of the triumphs of this technology is when the young woman, I think she's slicing a pear, and she's slicing the pear in very fine. Just imagine in a normal, rather simplistic hand prosthetic, that would probably be virtually impossible to be that articulate, is my point. And that's where all this technology is coming together. I love this story. It's a great one.
Definitely. I can't wait to see this for myself one day. So there you go.
Yeah.
And everyone, once again, you can check out the show notes for more videos. And of course, I have a YouTube channel as well. But let's go ahead and, hand it off to, I don't know if that was in bad taste or not, hand it off to story number 3. Maybe Bionic handed off. Maybe Bionic handed off.
I think it's perfectly okay. So the next story comes from arstechnica.com, which is a wonderful outlet, by the way, everybody. Headline here is battery-powered freight locomotives are picking up speed. It's a kind of a tongue-in-cheek headline, but a very important trend here. So, of course, as we all know, all-electric power is rapidly becoming commonplace in cars and trucks and is being tested in planes, helicopters, and this was interesting to me, even container ships. What? Wow. Okay. And by the way, here I'm in the Portland, Oregon area, as some of the listeners know. And just yesterday on our local news, they were talking about an all-electric big passenger bus service that's now going to shuttle between Portland and Seattle back and forth. I want to ride on that thing. I think that'd be a blast. And our local Portland Metro Transit organization is gradually introducing all electric large passenger commuter buses just for the normal routes as well. And there's a plan to integrate them. Yeah.
And before we even get started with this, I do just kind of want to mention that there have been some ambitious goals. I know that due to Russia and Ukraine, Germany moved their goal of phasing out natural, fossil fuels and natural gas, and maybe not natural gas, but anyways, from 2050 to 2035. California said they were going to stop selling combustion engines by 2030, I believe. Ralph,
wow.
These milestones, like in 10 years, all of them are hopefully going to be met. Like these. It just kind of hit me when you were describing what the initiatives that you're already seeing between the train and the buses and things like that. We're going to be hit with a deluge of these, because if you want to hit that 2030 deadline, I mean, everything's going to have to be transitioned in the next 7-8 years. It's going to keep happening, and thankfully too.
Yeah, and from a kind of culture shift, if you want to call it that, or a movement, if you want to call it that. A week ago tomorrow, my wife and I went to the big auto show. It's the first time since the COVID era that they actually put together the usual annual auto show, and all the manufacturers bring their cars. Without a doubt, the biggest crowd pleasers, the most people clustered around were for the all-electric vehicles. They had the Ford Lightning F-150 on display, for example. Just one example, of course, the Mustang that's all electric,
sure the Rivian was
and
there,
many
maybe?
other brands. Sorry?
I'm sure the Rivian was there, maybe?
No, I didn't see that. It was more like the mainstream guys, the GMCs, the Fords, Toyota, that sort of thing. But believe me, all electric was really the star of the show, and I think that was indicative of the consumer interest in that. And plug-in hybrids too, which we have. We have a RAV4 plug-in hybrid. Which, friends, if you're looking for going into electric transportation for yourself, and you're still a little worried about, well, if I take a 300-mile drive out to the country or something and there's no charging stations, what am I going to do? Look at a plug-in hybrid, because you can do your normal driving up to 40 some odd miles, in our case, 40, 45 miles, all electric. Then it goes into a regular hybrid mode, which means we don't have to worry about a charging station. It's sort of like the best of both worlds is in a transitional vehicle. So consider that. But back to our story
of course,
about all electric locomotives. So now, all-electric, battery-powered only technology is coming to big freight locomotives. The goal, no surprise, is to replace today's diesel-electric hybrid locomotives with a zero-emissions alternative. And I never really thought about freight trains. We have a big freight line not too far from our house, and we'll occasionally see the big freight trains going by, and never really gave it much thought. So turns out, and this was from my education, diesel electric hybrid locomotives work this way. The ignition of diesel fuel pushes pistons connected to an electric generator. The resulting electricity powers motors connected to the wheels of the locomotive. So that's why it's kind of like a hybrid. So with all electric locomotives, of course, the polluting diesel is cut out of the equation. That's the payoff on the ecology part of it. So recently, here's the news. Recently, Union Pacific Railroad agreed to buy initially, this is not the end of it, initially to buy 20 battery electric locomotives from an outfit called Wabtec, that's WABTEC, and Progress Rail. And I have links in the show notes to both of those outfits. The battery electric locomotives will offer up to 3,000 horsepower. And this, I think, is really interesting, Ben, and a runtime of up to 24 hours. That makes them very practical. That's pretty impressive. So, but how are they going to be used initially by Union Pacific? Initially, they'll be used to sort trains out in big rail yards in California and Nebraska. So they're not deploying them out for long haul or anything quite yet, but still, it's a start. And here's the big payoff. According to experts at the Lawrence Berkeley National Laboratory and UCLA's Institute of the Environment and Sustainability, using all electric locomotives could save railroads if they converted their entire fleet. So that's a qualifier. But it could save railroads an estimated $94 billion in fuel costs in the first 20 years of deployment. So there's a real motivation beyond just helping the climate, fighting climate change and all that good stuff.
There's so much to like about a 24-hour train that can just haul continuously, and you can imagine, just increasing this with battery swapping and things like that. I mean, this is the kind of thing that we need. And Ralph, I also do kind of find it funny that, anyone who knows American history in any capacity kind of thinks that trains, like, they really fell out of favor, especially in my early days. And, when I was a kid, trains weren't really like, they were used, but they weren't everyone's favorite. But like, America was built on trains. America was built on the rail system. And it's kind of fun to think that, even in a future where trains are seen as these big, messy, polluting things, trains are still going to, they're going to continue to be a thing for a long time to come. And that's really cool.
Yeah. No, it is really remarkable. You're absolutely spot on right about trains being so critical to the history of this country. Needless to say, now story number 4. I think you're going to love this one. This is just, I love it when people come up with ideas that might save the day. And let me explain. One of the things I love about the stories that I look for are ones that give us hope. As I said at the outset of the show, with everything going on in the world right now, God knows we need some hope and some feelings that maybe things are going to be okay in the long haul. And this story, I think, fits the bill. So the headline here is 12-mile deep holes could convert power plants from fossil fuel to geothermal. Well, right away, you had me at 12-mile deep holes. What's that all about, right? This comes from Fast Company. And this is another story, by the way, you'll see at the end, involving MIT. So here we go. Iceland was one of the first countries to move to 100% renewable electricity. I didn't know that. That's fascinating. In part because they can tap into geothermal energy from its unique volcano-filled geology. I think we all know that about Iceland, right? In many other places, that energy option, of course, isn't available. But, ding, 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 a new technology could make geothermal power accessible, I should say virtually anywhere on the planet. So here we go. Now there's a new startup called Quaise, that's Quaise, Quaise Energy, that plans to deploy millimeter wave-based drilling systems that can drill as far as 12 miles underground. And to put that in perspective, Ben, that's 3 to 5 times deeper than typical oil and gas drilling. And when you go 12 miles down, you reach a layer of hot rock. We're not talking about music here. You reach a layer of hot rock with temperatures of 700 degrees Fahrenheit or more. And it's constant heat source. And that heat can be used as a constant power source essentially anywhere on the planet. And the millimeter wave energy on the tip of the drill that they're using uses a much higher frequency version of what happens in a microwave in which you cook food. It's so high, in fact, I love this. This just blows my mind as well as melts it.
Uh-huh.
It's so high, the frequency, it can melt and vaporize rock. What? Okay, a little side note here. What is the difference between microwave and millimeter wave? Did a little additional research. So
Sure.
millimeter waves are electromagnetic radio waves typically defined to lie within the frequency range of 30 to 300 gigahertz. The microwave band is just below the millimeter wave band. Now, the millimeter wave band is typically defined to cover the 3 to, I'm sorry, I think I've got that wrong. I need to double check that. It's a much higher, I think the millimeter, now I'm stumbling around here. I know it's the much higher range.
Fact,
Can you help out with that?
Yeah, I know for a fact that one of the things that we always kind of warn people on the show about is that your microwave at home can actually mess with your Wi-Fi that operates in the 2.4 to 5 gigahertz. So I know that it has to at least encapsulate that because they kind of match wavelengths.
Right. Yeah, I got to double check. I just threw these notes in at the end here, but again,
Sure.
The point is that the millimeter waves are a much higher frequency, much higher frequency than what your microwave at home does.
Right.
And that's how it's able to melt and vaporize rocks. And in fact, my wife had a good comment. She said, well, this sounds kind of groovy that you can go down that far and tap this heat and have an endless supply of heat to generate electricity. Fine, that's all good. But isn't it kind of what happens if you poke a hole in the earth where you shouldn't? And what, we're going to have lava shooting up or something?
Of course,
weird?
you make a volcano. Yeah.
That's a fair concern. Anyway, so here's the link to MIT. The millimeter wave energy being used was developed by MIT's Plasma Science and Fusion Center. So another example of the range of what MIT is up to. And I just think, again, if you stop and think about what scientists are doing around the world on trying to tackle the problem of renewable, sustainable energy, I am intrigued with this idea of sending, drilling down to that depth where you have constant heat, as opposed to worrying about, is the wind strong enough to propel our wind things? Is the sun, how many solar fields can we build on this planet, and all this sort of stuff. But if you could just start drilling these very precise holes in different places and associate them with power plants and convert them to geothermal, this could be a really big game changer if it's safe, to my wife's concern and point. If it makes geological sense in terms of safety, then hey, we might be onto something here that could just utterly transform our energy, especially for poor nations, third world nations and so forth, where this could be possibly a really viable solution. We'll see.
Right. So, and now here's my job to be a little bit of a wet blanket, but I actually did hear about the story a little while ago, and I recall the conversation happening around it, Ralph, is that first off, you got to think about that, they want to drill 12 miles, about 19 kilometers, and I don't know why, but all the holes on Earth are measured in kilometers. The deepest, actually, this might be a fun fact for you, Ralph, what is the current deepest hole, or was the depth of the current deepest hole? And it's the Kola Super Deep Borehole. How deep do you think they got?
I give up. Tell me. That sounds
about 12.2 kilometers. So, and that was, and if I recall, that was by the startup that was in the early 2000s. They got 12 kilometers down. Their drill bits got stuck and they kind of melted in the super high pressure, heat of where they were kind of operating. Ralph, like this startup, and like I hope that they do it. Like this has so much potential. And technology and, metamaterials and everything that we talk about on the show here today has improved, but they want to dig almost twice as deep as any hole that's ever been dug before, just this startup. So I'm hoping that they're getting it, but they have a monumental task. Like no one's ever been able to do this before. I just hope that they can do it.
Well, it'll be interesting to see if this millimeter wave technology is possibly the key to making this possible. And by the way, going back to I don't know why I stumbled on that little thing. So again, I just want to clarify.
More coffee.
So we said first, yes, well, I've been sipping coffee. I was hoping it would help. So millimeter waves, again, are typically defined to lie within the frequency range of 30 to 300 gigahertz. So that's the millimeter waves, and that's the technology used in this drill bit. Microwave, I don't know why I stumbled on this. Microwave is much lower. That's only in the 3 to 30 gigahertz range. So you go 3 to 30 gigahertz, that's your microwave like in your oven at home.
Mm-hmm.
And then when you go 30 to 300, that's the millimeter wave. So I don't know why I stumbled on that before.
Too many threes. Too many threes.
Yeah, that was it. It was just too much.
you definitely got the good information out, and everyone, of course, you can go check this out because I mean they have a website.
Yes.
They're headed by very intelligent people. So let's hope that they can get all of this kind of up and running. So everyone, if you like, check that out. Links in the show notes. We'll have that up here shortly. And I want to thank everyone, and of course, a big thanks to Ralph for coming on the show every Friday and sharing these with us. So Ralph, I hope that you have a great weekend. Everyone else, I can't think of a better way to spend our Fridays than with Ralph. I hope you have a great weekend too, and you have fun. And everyone, stay safe. Thank you so much. Bye, everyone.